Hey, Tapping Airlines Math and History, and let's continue discussing and reviewing the properties and operations. Let's move on to the properties of inequality. So, let's start with the addition, because when you're doing properties of inequality, they all work for all operations, all four operations. So let's start with addition. When we're doing, for example, x, subtract that by 10 is going to equal 40. But how is this addition? Because we have a subtraction problem right here. We have to get x alone. We're going to get an answer of x equals. But we have that 10 to deal with. So we got to move that 10 to the other side to have that 40 with. So we're going to actually add that by 10 and add this by 10. And we just get x equals 50. So pretty much what we did for the addition is the property of inequality, but for addition. This is addition. Let's now do subtraction. Subtraction is actually a complete opposite of addition. Because if we have x plus 10 equals 40 instead, what we're going to have to do is get x alone again, but subtract that by 10 and subtract that by 10. So when you have an addition, it'll become a subtraction, and if you have a subtraction, it'll become addition. So pretty much, we subtract both sides. And 40 minus 10 is 30. For this scenario, x will equal 30. This can tell us that the addition sign is going to be arch enemies with the subtraction sign when it comes to properties of inequality. But what about division and multiplication? What kind of rules do they have? So, with multiplication, what happens if we get an example of x divided by 5 is going to equal 10? The thing is, since it's division, we have to get the x alone. So we have to multiply by our denominator, by 5, by both sides. Then when we do that, since we multiply by 5, what we did is we cancel them out. So we just have x equals 10 times 5. And 10 times 5 is 50. So for multiplication, x is going to equal 50. When you see a division problem, when you have that x, if you want to have that x alone or isolated, you want to multiply, because that's the opposite of division. But with division, if we have a problem like 5x equals 35 and you want to get x alone, we have to divide by 5 because we multiply in this scenario. So doing the opposite is actually dividing by 5. So now we get an answer of x equals 7. When we do 35 divided by 5. X is going to equal 7. So that can tell us that the multiplication symbol and the division symbol is actually going to be arch enemies with each other. They're the exact opposite. So addition and subtraction and multiplying and dividing. Addition and subtraction are against each other, and multiplying and dividing are against each other. These are all the examples of properties of equalities. With all four operations. Here's an easy one that we can take a look at. The inverse property. And that will only work with addition and multiplication. Let's start with addition. What happens if we have an example of 37, negative 37 plus 37 equals 0? That's the inverse property, because in order to get from the number to 0, you're going to have to add or subtract to get to 0. Like, if you're at negative 37 and you want to get to 0, you have to add 37 to get to 0. So pretty much, you're adding the opposite to get to 0. If we have 37 and we want to get to 0 again, we subtract that by 37 to get to 0. What about multiplication? With multiplication, what we're going to do is have the reciprocal. So multiplication is when we divide fractions, like 4 over 7, divide by 4 over 7. What we can do is multiply 4 over 7 by 7 over 4. The reciprocal is switching the numbers in the fraction around. So 4 is now on the bottom and 7 is now on the top. So when we do that, this will only work if our answer is going to equal 1. We only call it the inverse property of multiplication if the answer is 1. This is the last thing we're going to be doing, and it is the identity property. So that means when we add and multiply, what you want to do is, if you want to have a number stay the same, like negative 100, and your teacher tells you to write an equation, but it has to be negative 100, what you can do is add that by 0 to make it stay the same. Or with multiplication, we can have negative 100 again, but multiply by 1 to get our answer as negative 100. So the identity property is telling you, okay, I want you to stay the same. And this is our final move for what we do in math. All the moves that we just talked about and discussed is actually stuff that we've been doing last year and as review work, but we're going to actually use this for a step for higher level math. If your high school is really strict on how do you get this answer and how do you prove it, then these examples that we just showed you are actually going to help you climb up the stairs and answer your questions in higher level math. The examples that we just did actually have an abbreviation. And here are the abbreviations with all the subjects that we discussed on a list. Pause the video if you need more time to understand the abbreviations and what they are. I hope this video has helped you understand what the properties and operations are. Thank you for watching Tao Ping Airlines Math Industry. Like and subscribe. And to end the video, let's watch someone do a T-spin in Tetris. A T-spin is when you have a block that looks like a rectangle and a square right here, and you rotate the piece 360 degrees. That's when you call this move a T-spin, because it spins in Tetris.